What I'm going to show here is using this vacuum adapter that I've made for the mostly printed CNC. It incorporates a brush. It also incorporates a tire inflation needle that's spraying compressed air directly at the tooltip, and that does a couple of things. It cools the tooltip and cools the material. I'm machining Lexan, or just acrylic plastic or whatever, and it's kind of hard to get this spindle to slow down to where I need it to be. So what I had to do was come up with some way to cool it a little bit. But when I was machining Lexan, it would blow swarf all over the place. It looked like it snowed here in my shop, and it just took hours to clean up, and it was a huge pain. So what I designed is a manifold that also is incorporated into the lower mount of the spindle for the MPCNC, and the outer portion of that mount is a dust shoe with a brush installed in it. That the purpose of it is to give a little bit. I think at this point I need to lower the brush a little bit more, or possibly go with a little bit longer brush. But what I've done here in 3 videos is, the first video shows with no vacuum and no compressed air, and then there'll be a picture right after that showing how much chips or swarf is left all over the bed that has to be cleaned up with a vacuum cleaner afterward. And these are just little 15 millimeter by 15 millimeter cutouts, pockets that are only 2 millimeters deep. So it's not like it's creating tons of chips. But the second video is exactly the same thing, except with only the vacuum on, and a picture thereafter showing the chips on the table. And you can see that there's less, but there's still some chips on the table. The third video is exactly the same thing again, but this time it has the vacuum on and the air jet is on, blowing at the tooltip. And keep in mind, it blows the air down at the tool, and the vacuum is on the other side of it, the vacuum dust cover. So it's actually blowing the chips past the tool up into the dust cover, or the dust shoe. That's the hope. But the final one will also show the chips that remain after milling that pocket, and I have a picture of it, and there's almost no chips remain. Again, I think I can do a little bit better with possibly a longer brush, or increasing the length of the dust shoe itself so the brush is closer to the deck. The higher it is, the less, the more leak there is of the vacuum, meaning the vacuum isn't directed specifically toward the chip stream that's flowing toward it. It can leak out from underneath the brushes, and you know, so it's not as powerful. Plus, it also leaves room for chips to go underneath the brushes. So let's see how it works. Hope you guys are interested in it. I've worked real hard on this. It's going to be free. I'm not charging anybody for it. As far as the STL files, you can take them and print them to your heart's content, change them if you want to. You can't take them and sell them because they're mine, but you can print them all you want. You know, that's up to you. So take a look.